Welcome to another edition of the video series for the course Mathematics for Elementary School Teachers. This one is focused on the Common Core State Standards for Mathematical Practice, which cross all grade levels. Teaching math is more than just memorizing rules and formulas or getting correct answers. Starting with the problem of the day and going into a math lesson, teachers can engage students fully in the process of critical thinking about mathematics. The Common Core State Standards seek to develop depth of understanding in order to solidify ideas with rigor while also developing fluency and conceptual mastery. However, it is important to note that the curriculum should be relevant and appropriate for both the students and the school. There is an umbrella of 8 mathematical practices which we will discuss today, but there is also greater specificity when broken down by grade level, domains, clusters, and standards. Look more in depth into these and discover how you might teach a class in which your students are deeply engaged. How can they develop collaborative problem solving rather than just doing repetitive math problems? In order to better understand each of the 8 mathematical practices, I will briefly explain and clarify each one. The first mathematical practice says, make sense of problems and persevere in solving them. This practice begins with some explanation of ideas and definitions while providing a context for the day's lesson. Students listening to the presentation and asking questions for clarification can better conceptualize the problem, analyze what is given, and determine if there are constraints or relationships. Then, using George Polya's 4-step problem-solving approach, they can plan a method for the solution, plan a method for finding the solution, solve the problem, and check to see if the answer makes sense. The second standard says, reason abstractly and quantitatively. Comparing quantities and understanding relationships is a key to using both numerical and abstract symbols and operations. Developing quantitative reasoning allows students to put information into context, understand units, calculate and apply arithmetic, algebraic, and geometric properties. The third mathematical practice says construct viable arguments and critique the reasoning of others. In this standard, students learn to use assumptions, definitions, theorems, and other rules in constructing arguments. Students learn to analyze situations, justify conclusions, and defend arguments either by inductive or deductive reasoning. Elementary school students may construct concrete references like objects, drawings, or diagrams. Students can then find flaws in order to clarify and improve their arguments. Students can practice reading and listening to information, ask probing questions to understand the material more deeply, and make sense of arguments. The fourth mathematical practice says model with mathematics. Modeling is the creation of a representation that relates to or is familiar to a given situation. For example, a student might want to know a distance, size, or proportion from only a limited amount of information. This standard provides a context to explain real-world situations, to draw conclusions based upon grounded assumptions, estimations, and approximations. This is critical to contextualizing information. The fifth mathematical practice says use appropriate tools strategically. Historically, mathematicians used chalk, charcoal, rulers, protractors, and a compass. But today, there are many digital tools available, including calculators, computational software, statistical packages, animated geometry packages, and video tools. One of the key decisions students must make is which tool is the most appropriate or the best resource to pose or solve problems and deepen the understanding of the material. The sixth mathematical practice says to attend to precision. The exactness of an answer may mean life and death. When the Space Shuttle Challenger blew up January 28, 1986, it was determined that the reason was because of an O-ring. The O-ring was supposed to close more tightly due to forces generated at ignition, yet they were not precise enough. Suddenly, 73 seconds after liftoff, an explosion occurred. In this horrific accident, 7 crew members died, including the first teacher to go into space, Krista McAuliffe, a middle school teacher chosen from among 11,000 teachers. Sometimes, when teachers deduct points for not being exact, it appears to be a devastating penalty. However, details like labeling the axis, specifying units of measure, taking a certain number of decimals, and rounding decimals are sometimes extremely important. In fact, it can be a matter of life and death. The 7th mathematical practice says look for and make use of structure. For some, rules like the commutative property are intuitive. For example, 5 plus 6 is 11 and 6 plus 5 is also 11. Or 5 times 6 is 30 and 6 times 5 is also 30. Yet it may not be quite as apparent to students to understand that 5 minus 6 is not the same as 6 minus 5, or 5 divided by 6 is not the same as 6 divided by 5. Applying the commutative property to addition and multiplications seems inductively logical to apply the same rule to subtraction and multiplication, but inductive reasoning does not apply to every circumstance. In another example, looking for and making use of structure, students should recognize that multiplying out a polynomial is the reverse of factoring that same polynomial. We will cover that concept in this class as well. Finally, the 8th Common Core State Standard for Mathematical Practice says, look for and express regularity in repeated reasoning. Since students practice examples of math problems and repeat examples with different numbers, over time, it is evident that there are faster ways of computing the answer, shortcuts to solving the problem, or alternate ways to checking the answer. For example, some elementary school students quickly figure out that 2 has no remainder when dividing into an even number, but 3 always has a remainder when dividing into an even number. In this way, they begin to understand what it means to be divisible. This is the end of this video on the Common Core State Standards for Mathematical Practice. Having a better understanding of the overall picture of these general practices will allow you to be more in tune with the Common Core in general and the possibilities available in teaching mathematics. This is Dr. Rachel Winston signing off and wishing you great success in your teaching career.